Good morning. So, I was watching, surprise, I was watching some Alan Kay videos, and this time it was more about just small talk in general. And the idea of so in the 70s, Xerox decided that they wanted to get into personal computing, and they had more money than God, because God doesn't need money, but that was enough money for them to just hire pretty much everyone that was amazing and shove them into a single location. They called it Xerox Park. And they asked the questions, they were in the position, they were uniquely positioned to ask the question, not only what should a computer be and do, and what can it be and do, but also how should people interact with it? How should people use it? How should people address a computer? Like, what does the interface need to be? And what they kind of settled on was the idea that if a child can do it, it can be intuitive enough for pretty much anyone to do it. So that was kind of the goal, and that was their test group, was children, usually around 10 and early teens. So they took these kids, and taught them how to use Smalltalk, how to use the programming language. And part of the goal of Smalltalk, in the first object-oriented, technically, language, was to make it so that everything had kind of an understandable container. It was an understandable shape. If you're playing around with Legos and you have a general idea of how the Legos fit together, then if one Lego's a little bit fatter or one Lego's a little bit thinner or shorter, you still basically have an understanding how they work. And if you don't, maybe you do a build and the instructions say, use this piece like this, and you go, oh, okay, I understand. The point was that it was very kinesthetic. It was something that you were hands-on with. You were moving things around. You were making changes and then trying things and then seeing what happened. And then afterwards you go, okay, well, let's change it back, or let's try something different. Or, yes, that was successful, let's move on to the next thing. And the result was these kids. One of them was a 12-year-old boy that was getting into ham radio. So he made a circuit symbol generator and circuit diagram creator, like a graphical thing to create circuit diagrams. And you could kind of map them out, and if you didn't like one, you could swap it to another one. You're not just drawing directly on the screen, you're treating these circuit diagram things as objects that can be moved around or removed around and have their own properties. And this 12-year-old boy made it, and it was like, the other thing was like the brevity of the language. It's like the idea or the goal was that a language should be able to fit, or rather an entire program should be able to fit in one page of the Alto's text or syntax. And this is not high resolution stuff. So you have these programs that you can essentially look at almost in their entirety on a single small screen. And you can more or less read, with a little bit of understanding, a little bit of practice. And it makes the whole thing less daunting. It makes everything more understandable, more accessible. And they came out with the Alto machine, and they developed Smalltalk and did all kinds of other things from there. And for a variety of reasons, Xerox didn't. Xerox kind of abandoned the project. It didn't want to do it. And fortunately, or unfortunately, I guess, Steve Jobs got himself a way to take a sneak peek at this, to get a demo of what they were doing at Xerox Park. And they knew that he was going to draw inspiration for someone who wore out the patent system. That guy is just a piece of work. But he drew his inspiration, and suddenly there was a graphical user interface. Like, there were windows, there were things that you clicked and dragged and moved, there were work areas, separate workspaces. That was my brain did a little flip when I saw that, because when I was a kid, I was like, man, I wish Windows had like a workspace kind of idea, where it was like I could work here and then I could walk over here where everything was blank and rearrange things over there. So much of this stuff is like, oh, that would be neat. Well, it was already done in the 70s, and Spoiler alert, it was too full-featured. Like, that was the thing. Oh, sorry, that 12-year-old that did the the circuit diagram program, he said that someone later got some award for developing something similar in another language as a PhD, as a thesis, basically. And it's a 12-year-old doing it. So the idea that you can take computers and make them so accessible that children can use them, and develop their so easy to use with that language system and graphical interface that you create production level software, you create corporate level, that's a joke, corporate level software. That's why the software industry shouldn't exist. That's why, because all of this should be so easy that if you think, man, I sure would like a spreadsheet that could do this, you just write one. You write one in a weekend, and that's it. And if someone else really likes your spreadsheet thingy, then you can send it to them. It's a single page. We could even go back to those computer books, the basic computer books where you buy a magazine essentially, and you turn the page and you go, oh, this looks like a fun program. I'll just type it directly into my computer, and hey presto, I have the game, I have the product, I have the tool, whatever it is. It's just so unbelievable what the industry decided they didn't want. It's disempowering, and it's very, very frustrating. But that's not entirely what I wanted to talk about. So I think about that, and I think about OneNote, which I really enjoy using because it feels very intuitive. It feels my brain just clicks perfectly with the ability to take a picture and drop it on the screen, and take another picture and drop it on the screen, and maybe write some text out, and then take a pen and go scribble, scribble, scribble. I don't like this. This line goes to here, this goes up there, this comes around there, and then that means I have to do something like this, and then that is, 33.8 degrees or 338 degrees, and on this side it's 26 degrees, and like figuring out all that stuff semi-visually, semi-logically. That's the whole concept of that other video. Doing with images makes symbols. It creates that understanding starting from a kinesthetic level, and the concepts of the Dynabook where you're just like you can hand it to a child. And here's the Dynabook. Here you go, and here's a pen, and it's like okay, I get it. Like there's no instruction. It's just intuitive. That's the thing. That's the point. It's like there's no user interface. There's nothing more anthropocentric than taking like the circuit diagram thing and saying, I am a human and I am capable of taking a pencil and writing on paper, but after I draw a symbol on the paper, I wish I could just pick up that symbol, cut it out and move it over here and then paste it. And to say, well, I have a computer. Can't the computer display graphics and things like that and allow me to move those graphics around the screen and contextualize a circuit in my brain, or be a learning aid for me to visualize this circuit and write notes in it and plan it out, and hey presto, share it with other people too. Just the idea that like, I talk a lot about user interface, and this is the concept of, it's not like what should the user interface be, it's why should the user interface be. If you've got a Dynabook, or the ideal Dynabook, and you hand it to a child and hand them a stylus and they start scribbling on it and writing on it, and they make letters and it turns into text, and they go, oh, I get it. Like there's no instruction. There's no user interface. You're taking the entire world of experience, the experience that takes place outside of this computer, and you're applying it to the computer rather than you trying to shut off your brain about all the things that happen outside of the computer and think, okay, I'm in computer mode now. We're in big brain computer time now. I have to shift gears, pull out of that gear, move over here, and grind my gears, get into that gear mode of thinking about computers. Thinking like the computer rather than the computer thinking like you. It's just disappointing. But I think about that, and then I think about, he also said that, like, he said there was no modality in it, and I was like, oh, because I love the modal idea of Vim, of the interface like that, because it just expands the opportunities of the keyboard. It's still faster. I'm not going to say that handwriting is faster than typing. If you're a fast typist, it's certainly not. It is more intuitive. But that brings me back to the idea of like, okay, so what are these modes? And if you extend that into a keyboard, you know, that frame of reference, your keyboard is in modes, at least for a smaller keyboard. You hold down shift and the mode changes, so now your numbers 1 through 0 now do different things. You know, you're capitalizing alpha characters, which is fine and understandable and intuitive, but your 2 becomes an @ symbol, I guess. So that's additional thinking that is not necessarily required. It doesn't even need to be there. But the idea of that kind of reminded me about my keyboard and how, if I have like I talked about in the keyboard design philosophy meta-analysis video, where I had a failed hunting trip and just talked about it. It's about the not the confidence level, but I've created a complex user interface because I don't mind using one. And when I look at I was reminded of the pocket operator while I was thinking about this design, and the pocket operator has the exact same thing. It has an insane amount of modality. It has so few buttons that the buttons change so often based on whatever the context is, and that even the dials that are movable, those change context based on whatever mode or whatever context you're in. You have to be, you know, it's almost big brain time to figure it out. But musicians who are, you know, musicians are not generally not the most academic. They're very creative types, obviously. Musicians are able to take this ridiculous user interface and fiddle around with it, and they do with other, like, much more complicated pieces of hardware that do you know, synthesizers and samplers and stuff, and they basically just fiddle around with it until they figure out, hey, I get it, this is what this does and this is what that does. Like, I understand how these pieces fit together. And after they do that, they start working normally with it without any issues. And most of the time, they might not even read the instruction book. You know, yeah, it's a little weird, but I kind of got used to it. You know, that is it's like the epitome of the kinesthetic learning style. You know, it's amazing. And this is something else that, like, something else that musicians understand pretty intuitively, at least the good ones, the ones that get work done, is the workflow. Because if you talk to, you know, the word menuing is a word that I first heard mentioned not in user interface design, but in music, in interfacing with musical devices. It's like, how much menuing do I have to do to change a thing that I would commonly change? And that's the heart of this user interface. It's like, I'm here, I want to get here. What is the shortest distance between here? You know, how long is this distance, and how inconvenient is that? And can I change that to be shorter? So I think about that. And I think about how this stuff is so unintuitive, and how the user interface is so unintuitive. How you have to walk up to it with an instruction manual to figure it out, unless you get enough context to be able to, or if you're freewheeling enough, I guess, to be able to say, I'll just mess around with this until I figured it out. But the other thing is, if it's daunting in the beginning, you create a mental block where you don't think you're able to do it, period. Like, you don't even think about starting because you don't even know where to start. Without a starting point that says, you know, start here, try this, mess around with that, you're just looking at something that makes no sense. And when you're looking at something that makes no sense, you have the Signum. You have my keyboard, my designed keyboard. And that is why my design is technically bad. I have faithfully reproduced, followed my design inspiration, which is the pocket operator. Visually and apparently logically, I've created bad design. A design that is very powerful, but you still have to learn it. You have to understand it. And you have to work your way up to the tool rather than the tool working its way down to you. Now, the thing that is frustrating is, once I had this realization, it's like, how do I apply this? The thing is that you can maintain that that level of complexity while adding more user friendliness. You don't have to sacrifice friendliness of the user interface to make it. You don't have to sacrifice the power for the friendliness of the user interface, because nothing that is logical about the keyboard right now needs to change in order to do that. There needs to be more accessibility in it, and that was a fun realization to have. Now, I am introducing complexity. I am making the product bad, and I am limiting how it improves the lives of people. And I need to change that.